Good morning, dear students. In previous class, we are discussed about logarithms and its formulas, problems, question answers, and previous question answers, model paper question answers, and these logarithms are comes under Unit 1, Chapter 1. Unit 1 contains two chapters. One is logarithms and second one is partial fractions. These two chapters are in Unit 1. So if we learn second chapter, then we will be completed the Unit 1. So logarithm and partial fractions both are different topics. There is no relation, there is no similarity in the logarithms and partial fractions. Here it is a new topic, and here we discuss the new methods in partial fractions. The methods are very simple because here we do partial fractions means first we take a fraction and it is expressed in a sum of two or more fractions. This process is called partial fractions. So to express more than two fractions, what is the procedure, what is the condition, what are the steps we have to proceed? Here we will learn. First of all, what is fraction? Then how to divide or how to express more than two fractions of a given fraction. First, we will know what is fraction. Fraction means which is in a p by q form, either that p or q in a number or a algebraic expression. Number means 2, 3, 4, 1, like. Other than number, instead of number, sometimes we will kept it is x, y, z, like. Sometimes it may be mixed with number and expression, that is x by 2, 1 by x into x minus 1, or 1 by x square plus 3x plus 2, like this. There may be any number of functions you can express in a fraction, and the fractions are, it may be two types, proper or improper. Proper means, for example, 1 by 2, numerator is 1 and denominator is 2. So by simple observation we say denominator is greater than numerator. So this type fractions we say is proper fraction. If numerator is bigger than the denominator, for example 3 by 2, then that fraction is called improper fraction. And proper fraction only divided into or expressed into some or more fractions. If improper is given, then we will convert it into a proper fraction. After that proper fraction, we will split into a 2 3 fractions, sum of 2 3 fractions. For example, 7 by 2 is a improper. By dividing 7 with 2, we will get proper. 7 by 2 means 2 3s are 6, so remainder is 1, and the quotient is 3, so 3 into 1 by 2. Here 1 by 2 is a proper, so 7 by 2 equal to 3.5. So 3 plus 1 by 2 we can say. So here 1 by 2 is a proper, so 1 by 2 again we will split as a number of fractions, sum of number of fractions. So the given fraction is proper, and we will do the more fractions, split into more fractions. Or if the given fraction is improper, so we have to do some more work. First we have to change it in proper, and that proper fraction we are convert, or we are express in the sum of more fractions. That is called partial fractions. Partial means partly, little. To understand, I will give you an example. If we take a chicken from outside, first he cuts into a pieces. So if all pieces we merged, it form a chicken. So he divided into so many pieces with knife or sharpened device. In the same way, with particular procedure, we will divide, we will split, we will express the fraction into a more than 2 3 fractions. The process, the rule is very simple. So here we will learn the rules, mainly 2 rules, and the remaining 2 rules are followed, a little bit difference only. And the process also simple, and we can easily understand. Then we will do, and we will know the example problems, and after we will do the exercise problems without difficulty. So from this, in the examination, we have 1 mark, 3 marks, 5 marks, like logarithm. So 9 marks we will get easily from logarithm, and as well as this chapter 2, partial fractions. So 9 18 marks we will cover easily. And let us see what is next slide. Here the question comes in previous. Write the types of fractions. So answer is 2 types are there in the fractions. Mainly they are proper fraction, and second one is improper fraction. Proper means numerator is less than the denominator. Improper means numerator is either greater than the denominator or equal to the denominator. For example, 4 by 4. 4 by 4 is comes under improper fraction, and 5 by 4 is also improper, but 4 by 5 is a proper. Next, we will learn what is proper fraction with example. See here, this type of question also came in previous paper or asked in the previous students, I mean your seniors. So the question is, define proper fraction and give one example. So if you want to give definition, we can write like this. The heading is proper fraction. The definition is as follows. In fraction, f of x by g of x f of x degree is less than the g of x, then the fraction is called proper fraction. So here p by q is nothing but f of x by g of x. F of x means the expression of the function in x. To separate numerator and denominator, we are expressing with f of x and g of x. Both are in the expressions of x. Both are the functions which are in the form are expressed in terms of x or x square, x cube, whatever it may be, including numbers with coefficients, additions, subtractions, or a product. So here the example is 1 by 2 and another example is x by x plus 2 into x plus 3. Here degree means the power of the x. In the numerator x power 1, so the f of x degree is 1, and in the denominator x plus 2 into x plus 3. If you multiply, we will get x square. That means x power 2. So here the denominator's degree is 2 and numerator's degree is 1. So denominator's degree is higher than the numerators. So by the definition, f of x is less degree than g of x degree. So it is satisfied. So we can say it is a proper fraction. For if we take this reverse, then it is an improper fraction. If f of x is bigger than the g of x or equal to the g of x degree, then we can say improper fraction. So if you know the proper fraction definition, then automatically you know, or you can write improper fraction because it is opposite. And one more thing is, in improper there is an equal also in degree, numerator and denominator. But in this chapter, the equal degrees we are not have more problem. We have the proper fractions and improper fractions with different degrees. There are only few problems which are equal degrees. It is also comes under improper fraction. So this is about proper and improper. Next, how the problems, how the procedure, what steps we have to do to express more than 2 or 3 fractions as a sum of a given fraction. Let us see. Next, the question is like this: resolve x by x minus 1 into x minus 2 into partial fractions. So the given fraction is we have to express in a sum of other two fractions. First of all, we have to observe the given question and decide is it proper or improper fraction. Here the given fraction is proper, that is x by x minus 1 into x minus 2. The numerator's degree is 1 and the denominator's degree is 2. And moreover, next we have to observe here it is proper fraction, so there is no need to convert into another proper fraction because it is already proper. And next step we have to observe the denominator contains in the factors form or not. So here clearly given two factors, one is x minus 1 and another is x minus 2. So these factors are, we say, simple factors or linear factors. For this type of factors we have one procedure, that is to split the partial fraction. To express the partial fractions we have to follow the rule, that is here we mention see a by x minus 1 plus b by x minus 2. For two factors we wrote two fractions, in between we kept plus symbol. So sum of two fractions we are expressing because two factors are there. So consider it as equation 1. Next, in the right side, if we took the LCM, we get x minus 1 into x minus 2 as a LCM. Left side also we have same denominator, so left and right side both are get cancelled. Then we have numerators. In the left side we have x, and in the right side after LCM we get a into x minus 2 plus b into x minus 1. Consider it as a equation 2. And here we have to find AB values, then only we get the two fractions. To get A, we have to remove the B. So here we cannot directly remove B, but if we observe its product, if we put x equals to 1 in equation 2, then 1 minus 1 is 0, 0 into b is 0, so b will be suppressed or vanished. So if we put x equals to 1 in equation 2, automatically b will be removed, then a is there, so by simplification we get a value. So put x equals to 1 in equation 2, then therefore 1 equals to, wherever x is there in left and right hand, we have to put 1. So 1 equals to a into 1 minus 2. Here b is not writing because it is a 0. So 0 plus something, something. That something is a of 1 minus 2. 1 minus 2 means minus 1. A of minus 1. Then a equal to 1 by minus 1. Then a equal to minus 1. If you don't know 1 minus 2, then you use the calculator 1 minus 2 and press equal. On the display result is minus 1. you can see. So in exam you can take calculators. In our diploma exams it is allowed, so if you have any doubt you can use the calculator also. If you know, then no problem. If you don't know, or if you have any confusion, you can use. And next side I wrote put x equals to 2 in equation 2 to get b value, so that a is removed or a is vanished or a is 0. So 2 equals to b into 2 minus 1, then b equals to 2. So here finally we got a value and b value by substituting relevant numbers or relevant substitutions or digits. So after a and b, then we have to substitute its values in equation 1. So write a line, that is substitute the values of a and b in equation 1. Therefore x by x minus 1 into x minus 2 equals to minus 1 by x minus 1 plus 2 by x minus 2. So here we can say the given fraction is expressed as a sum of two fractions. So I think you understand the procedure and steps, and if you practice or if you do this type of problems, then it is easy to go for second, third, fourth rules. They are similar to this. Mainly if you know this first method, then they are very easy. You can see the examples, you will understand, and the remaining procedure is same. The first equation or first step, how to split depending on the factors, linear factors or repeated linear factors or quadratic factors. Like this, the splitting style is different. If we know that style, remaining LCM and finding the A, B, C, this type we will know and we knew, and if we don't know, we can see the examples, then we will understand and we can do. So the main thing is how to express based on the factors. And if we observe some more problems, we will more understand, or we will get more concept, or we will get more, what we say, we will get more idea about the splitting or expressions in terms of partial fractions. So the next question, if we observe, the question is resolve 1 by x into x minus 3 into partial fractions. Here the factors are, one is x and another one is x minus 3, the denominator. So based on this, these two are, we can say, simple or linear factors. So as we know in first problem or previous problem, how to express, that is a by x plus b by x minus 3. And next step, we are taking LCM and we will cancel the denominators after LCM. See the next step, both the denominators are cancelled and the remaining is 1 equals to a into x minus 3 plus b into x. I can see in third step and consider it as a equation 2. Now to get b value, I am taking or I am putting x equals to 3 in equation 2. Therefore 1 equals to a into 3 minus 3 plus b into 3. So 1 equals to a into 0 0 plus b into 3 3b or b3. So we need b. So here 3 is a multiplying or product or a coefficient to the b. So if we send left side, it is 1 by 3. So we get b equal to 1 by 3. Next, to get a value in the equation, from the equation 2, we have to put x equals to 0. So right here, put x equals to 0 in equation 2. Then therefore 1 equals to a of 0 minus 3 plus b of 0. So b of 0 means it is 0. So 0 we need not to write. Then 1 equal to a of minus 3. Then a equals to 1 by minus 3. So substitute the values of a and b in equation 1. Then we will get minus 1 by 3 by x plus 1 by 3 by x minus 3. So finally we got the fractions. So these fractions are called partial fractions. The given fraction is expressed as a sum of two fractions. Next, here in the question already they are given they are expressed in a fractions, partial fractions, but in that fractions one value is not given, so we have to find that value. Instead of value they are given a letter a. See here, the question is 2x by x plus 7 into x minus 7 equals to 1 by x plus 7 plus a by x minus 7. Then find the value of a. The question is we have to find a. So already they are expressed in terms or in the sum of two fractions. So now we have to do the simplification. So in the right side we took LCM. Now here the both sides denominator is same. So after cancelling denominators we have 2x equals to x minus 7 plus a into x plus 7. Let it be equation 1, or take as it equation 1. Next, to get a value, put x equals to 7 in equation 1. Then left side we have 2 into 7, and right side that is equals to 7 minus 7 plus a into 7 plus 7. The left side 2 into 7 is 14. The right side a into 14. So if we take the 14 to the left, 14 by 14 will get cancelled and remains 1. So a value is 1. So here already fractions are there, but one value is missing. So we are found that value. Next, question. This is a 3 marks question. Question is resolve x plus 1 by x square plus 5x plus 6 into partial fractions. So the given fraction is not in the form of factors at denominator. So first we have to convert it into a factors of the denominator. So factorization we have to do here. We know in school or in previous classes, that is 10th or 9th, in school education we know what is factorization or how to factorize the given function. So here first and last terms we have to take. In the first term x square coefficient is 1 and last term the constant 6. So 1 into 6 6, and observe the middle term, that is 5x. So the 6 we have to know, for 6 we have to know the factors, that is 2 3s are 6. If we add, is it equals to the middle term or not? If it is equal, we can write in place of 5x 3x plus 2x. So that is what we are written here. Next, in the denominator, first two terms we are taking x as a common, and the second two terms 2 is taking common, and after that here x plus 3 is a common. So again x plus 3 we take common, the remaining we have x plus 2. So the denominator now in the form of two factors, that is x plus 2 and x plus 3. Now if you observe, the two factors are linear. So to linear factors we know how to express the sum of fractions, that is a by x plus 2 plus b by x plus 3. Consider or give it as a equation 1. Next, follow the same procedure as we did in the previous questions or above previous slides. Take the LCM of the right side's fractions, and after cancelling, then we have x plus 1 equals to a of x plus 3 plus b of x plus 2. Consider it as the equation 2. Next, put x equals to minus 2 in equation 2 so that we get a value. So after substituting x equals to minus 2, we have minus 2 plus 1 equals to a of minus 2 plus 3 plus b of minus 2 plus 2, and in the left side minus 1 have that equal to the right side a of 1. So a equal to minus 1. Now to get b value, we are substituting x equals to minus 3 in equation 2. So why we should put minus 3 means, to remove a, we have to observe the factor which is in the product. We kept minus 3, then it becomes 0. So coefficient is 0 means it is suppressed or it is vanished automatically, because 0 into anything is 0. So here taking x equals to minus 3 in equation 2. So the next step is, therefore minus 3 plus 1 equals to a of minus 3 plus 3 plus b of minus 3 plus 2. Then next step, minus 2 equals to b of minus 1. both sides we have negative, so we can cancel and then b equal to 2. At the end we got a and b values, so substitute the values of a and b in equation 1. Then we get the quotient equals to minus 1 by x plus 2 plus 2 by x plus 3. This is what the partial fractions. Suppose in the factors, if it is a repeated factor is there, then what we have to do? This comes under second rule. See here in the left side, in the denominator, x square and x minus 2. So x minus 2 is a one factor that is linear and not repeated, but x square means x into x, that means one factor is repeated twice and that factor is also a linear. So here how to split we have to know. See, 2 times repeated means we have to take two fractions like this. See here on the right side we are expressing that is a by x plus b by x square. For x minus 2 we can write plus c by x minus 2. So here we have to observe, if number of times it is repeated, that number of fractions will be increased or expressed. Here x square means a and b came, and under a we write one factor and b we repeated factor taken. If x cube is given, then we can write c by x power 3. So it is like a ascending order. We can take one by one how many times it is repeated at up to that, such that we will take the fractions, and we in the denominator we will take step by step increase. So I think you got here. This is second rule, and remaining procedure same. To know a, b, c, we have to take LCM and we have to simplify by putting a required number to get a or b or c. So as we know in previous slides or questions like that, you can also see the examples. Also there are sometimes substitution method, or we cannot put directly, then we have to simplify, compare the coefficients, then we can, after comparing, we can frame in equations, and then 2-3 equations will becomes, and that 2-3 equations we will solve, and from that solving we will get a, b, c or whatever. So this is the second rule. So it is very simple, just we have to understand how many times it is repeated. According to that repetition we will write the fractions. Next, based on rule 2, we are here having a question. See, resolve into partial fractions. Here I am using with my mobile. So at your home, if you have a laptop, the presentation shows bigger and you can see clearly. So here you have to listen carefully, because my voice is audible to you, and if the slide is not clear or not visible due to mobile, but voice is, if you catch, you can overcome this small issue. of the vision or video, or what we say, the picture. See here, 9 by x minus 1 into x plus 2 whole square. Here second factor is repeated twice. According to that, we are split into three fractions. See here, the question equals to a by x minus 1 plus b by x plus 2 plus c by x plus 2 whole square. So this is a second form and it's considered as equation 1. Now here we have to find a, b, c, 3, because second factor is twice. So just second, I will call you. Okay, I received one call in between one call. Just wait. Just a second. Wait for a moment. So now we will come to our presentation. See here, in the right side we took LCM, and after LCM we have same denominators to both sides, so cancel the denominator. Then remaining terms are 9 equals to a of x plus 2 whole square plus b of x minus 2 x minus 1 into x plus 2 plus c of x minus 1. Consider it as equation 2. Now put x equals to 1 in equation 2 so that we will get a value. So 9 equal to a into 9, then a equals to 1. Next put x equals to minus 2 in equation 2, then 9 equals to c into minus 2, that is c into minus 3. C equals to 9 by minus 3, then c equals to minus 3. Now there is a difficult to get b value by putting the numbers. So here we are following different method. From equation 2 we are simplifying, that means we are multiplying. If it is in the factors, then after multiplying we will compare the coefficients. See here, from equation 2, 9 equal to, we can write a of x square plus 2 square plus 2x into 2 plus b of x square plus 2x minus 2 and plus cx minus x minus c. From again, if we multiply with a, so we have ax square plus 4a square plus 4xa. Like next, in second term we are multiplying with b, which is kept in bracket, so bx square plus bx minus 2b, and then we have cx minus c. So compare the coefficients of x square in equation 3, then therefore we have 0 equals to a plus b, then b equal to minus a, b equal to minus 1. Since a equals to 1, substitute the values of a, b, c in equation 1, then we get the fractions. So this is the partial fractions. And in the third rule, if the factors are quadrature, that is x square plus 2, then we have to write the split. To split that, we have to write bx plus c or ax plus b. So you see in examples, and if you not understand, I will explain. I will clear your doubts. So first you do the exercise problems, and observe the example problems also. And if you have any doubts, we will discuss in next class. Thank you.